Hello everyone, welcome to my video where I explain how my script mandelbrot.py can be used to discover various features of the famous fractal. By the way, I uploaded mandelbrot.py to GitHub. I leave the link in the description of the video. I also added readme.mandelbrot with some instructions for the installation and some general remarks. Okay, let's get started. Discover this famous fractal. The first thing to do is, of course, zoom in. Here you can learn that you do this with the left mouse button. So I have a zoom level of 4. That means I magnify the plot by a factor of 4 with each click. And when I do this, if I come to an interesting region, I might choose another zoom level, maybe 2 or 1.5. Let's go there further. And I can use the middle mouse button to shift the plot without changing the magnification. This data here is quite important. When you start with the zoom, it is at 3. And with each click, the number is reduced. And so mandelbrot.py uses floating point numbers with 64-bit precision. So we have 13 significant decimals. That means this data can go down to 10 to the minus 13 about. After this you have only noise. So this number tells you how many clicks you can do. Okay. So I will go back to the original plot. I think now you know how to magnify the various parts of the Mandelbrot set. And now I come to coloring. Well, this is the most important part for displaying the Mandelbrot set. Yeah, it's always you select certain structures and then you want to make them kind of nice. You always have the problem that the contrast is rather low, and you will choose color maps and change other parameters to enhance the contrast and of course to choose beautiful colors. So currently we use the color map hot. In this pop-up menu colors, I selected those colors which I use most frequently. Under all colors you find all colors that appear in the matplotlib documentation. You can play with it, you can select different colors, it's just your choice. Now I go back to hot, and then here I have a check box for reversed. You can reverse the color map. What does this mean? Show you this debug feature. So this is the original color map. If I reverse it, you have a different mapping between escape counts and the colors. Then I can rotate the color map. You see here the effect in the main figure, and you can see what it does to the color map, rotating the color map. Okay, so I go back to 0. I can do this also, but going back to hot. So now I come to the normalization. This is how the escape counts are transformed to color values. And to explain this, I prepared one PowerPoint slide. So we start with escape counts. By the way, I mentioned escape counts, escape count fields, maximum number of iterations, and so on. And if you don't know what these words mean, please go to the video definitions where I explain these things. So we start with the escape counts. They are in the range from 0 to max iter. So this is the escape count field. And let me choose this one. So the escape count for the members of the Mandelbrot set is 1024. That's the maximum number of iterations. These numbers do not escape if they are iterated with this formula, and outside we have the different escape counts. So and then I make a normalization. If I calculate the field, I want to have the values independent of the maximum number of iterations, and so I make this normalization. But this is just my personal preference. Next, we have to choose window limits. So which of the escape counts are mapped to the final interval from 0 to 1. And this is done by means of vmin and vmax. Let me show you. So here we have vmin and vmax. I choose a linear norm. And then we can change vmin. And here we can see how the interval which is used for the normalization changes. Okay. And then we come to the normalization, and we can choose among different functions. We have a power norm, and let me see. I have this debugging. Okay, we have the power norm. We have logarithms. We have a linear norm, and we have others, which I do not show today. I normally use the first three. So the power norm. Here we have the exponent 0.225. We can go to 0.5, which means square root. So how does this work? Here we have the escape counts. This is our input data. And the range is from 0 to 1024, and we have to go to the range from 0 to 1. So we start here, maybe at 200. We go to this function, and then we read the value. This is a normalized value. And the important thing is that there's some stretching. You can see that in this range, quite a few, a small interval of the escape counts is mapped to a larger interval in the normalized values. And this is why this area is sparse. You can enhance this behavior going to 0.1 or reduce it to go to higher exponent. And if you go to 1, you have just a linear normalization. So, and then these curves are kind of identical. So this is the normalization, and then the question is of clipping. What happens to the escape counts outside this window? Well, if clipping is enabled, then all colors below vmin are mapped to the lowest color, and all colors above vmax are mapped to the highest color. So let me show you. So if the clipping is enabled, I enlarge vmin, and you can see how this peak is rising, and likewise you have the thing for the highest value, so to say. Remember, this is a logarithmic plot. Okay, this is clipping. So now we are in the interval from 0 to 1, and now we have to find the color index. This is again a mapping from 0 to 1 to 0 to 1024. I use 1024 colors. Many people use 256 colors. I use I increase this number because I want to have smooth transitions. Yeah. In matplotlib this is very easy because color maps are objects, and you can sample them however you like. Okay, now I can close this, and you know how what these terms like vmin, vmax, and normalization mean. Okay, I think I should show you how this is working in action, so to say. So I go to this area. I chose this region. I think this is called value of elephants or so. I think this is the trunk of the elephant. This is the head, and these are somehow the feet. Anyway, so Then I magnify by a factor of 2. So I think this is the region which I wanted to select. So don't like these dark dots, so I increase the maximum number of iterations. They are gone. And then we can play a little bit with the color. This looks nice, but we can also use a different color map. So I'll use this one. I think this is real fun. Now we can switch on shading, maybe increase the vertical exaggeration a bit, and blend mode. So usually I use overlay, but I show you here what HSV means, or soft. It's a matter of taste. I use overlay, and then I smooth. Okay, now I think this looks quite nice, and you can rotate the color map, and you can see how the color, so to say, flows into the structure. I think it's quite nice. So if you like a specific location and you want to, you know that you want to revisit it at some point in time, you can store this. So I've done this. And if you start the program, maybe, then you can go to places, and then you find what you just stored, and then you can continue working on this. This is not a dead image, so to say. All the numbers which are filled in this graphical user interface have been updated. So then you could zoom into a different location and shift and do whatever you like. Okay, this was one example. I go to a different region. Maybe here, I think there's also famous things. Yes. Okay. We have black dots. You remove them by increasing iteration limits, and still some dots, and we can suppress them with an interpolation. Sometimes I use this Gaussian. And then, okay, we have always a problem to enhance the contrast, yeah? So we can again try a different exponent. Well, yeah, maybe it's better. We can try to reverse the color map. Okay. This is already quite nice. Again, think about shading. Maybe go a little bit closer. And smoothing. Or go to a different color map. Not reverse. Then we can rotate through it, and I don't know. So I really don't know. It's a matter of taste to find something which looks good. Okay. Then I like to show you the last example. It's in this area. There are structures that I really like. There, again, you have the problem of low contrast. Maybe I go here. And then you start to play. Maybe use logarithmic normalization function. Change the window limits. So reducing Vmax puts you more entries into the brightest colors, as you see. Maybe you think about reversing the color map. Go to the mother color map. Very colorful. Okay. So I think you got the idea. I will stop here. I hope you enjoyed this video and I thank you for watching.